Dear students, in the last lecture, we did the basic of partial derivative and function of two variables. Okay. Today, although about the limit and continuity in a single variable, but today we are going to discuss the limit and continuity in higher dimension, and then we will cover some part of partial derivative also. This is very much parallel to the limit and continuity in single variable. If you talk about the limit of a function of two variables, so we say that a function f of xy approaches the limit as limit capital L as xy approaches to x naught y naught, and it may be written as this. Okay, so this is limit xy tends to x naught y naught. F of xy is equal to capital L. You can say this is the limiting value of this function, limiting value of two variable function x and y. If for every number epsilon greater than 0, there exists a corresponding number del, means this would be very small but positive, such that for every xy in the domain of f, modulus of f of xy minus L should be less than epsilon. So this is very much parallel to the limit of the single variable function, where this under root x minus x naught plus y minus y naught whole square, this should be less than in between 0 and del. And but you mind it, both the points are in neighborhood, means they are positive and they are very close to each other, because this is less than del. Okay, so all the results, limit x tends to y tends to x naught y naught, x is equal to x naught. You may also say this is y is equal to y naught, or for a function value k, you may say this is equal to limit, this limiting is 10 to k is equal to k. Okay, for example, this is a simple example. Evaluate the function, the value of f of xyz is equal to this. Then how you can find out if the variable are more than two? Agar more than two variables are there, then also you can find out the value. How you will find out or evaluate the function for three variables x, y, z? The example is here. The function of two variable, there are a few problems. Functions w is equal to, w is always the function of x and y. So you can write w is equal to, let us suppose the function is under root y square minus x square. Then domain is, of course, y should be greater than or equal to x square. Okay, and the range is the closed open interval 0 to infinity. If this function is w is equal to 1 over xy, 1 divided by xy, where xy should, this domain is xy, of course, xy should not be equal to 0. This is non-zero, and range, of course, minus infinity to 0, union 0 to infinity. If the function is like this, the sine of xy, then entire plane means minus 1 to 1. So similarly, you can do some practice about the function of two variable or higher dimension. So this is, since till date you are habitual for the single variable, so this is my advice. You should do some practice to write the for the higher dimension function, similar as discussed here. Okay, so you get some practice about this. Whenever we define the limit in the basic, the point should be in a close neighborhood. So here we have taken regarding the circle and disk. Let us suppose if x square plus y square is less than 1, it means open unit disk. Okay, this is open unit disk. Every point an interior point. All the point is an interior point. Okay, but if this is equal to 1, then point including the circumference. Point including a circumference. Here it was here. Okay, and if this is less than or equal to 1, it means the closed unit disk contains all boundary points. So this is all boundary points. Okay, so this is the meaning of the interior point and boundary point of the unit disk in the plane. Okay, so I think this is clear to you. Bounded and unbounded region in the plane. What is the meaning of this? A region in the plane is bounded if it lies inside a disk of fixed radius. A region is unbounded if it is not bounded. Okay, if it is not bounded, then this is called unbounded. So these definition may be utilized during the solution of numerical problems. One very important definition is level curve, graph and surface. So already we discussed about the surface whenever I discuss f of x y is equal to z. Again, this is in a different manner, it is written the same thing. The set of all points in the plane where a function f of xy is C is called the label curve, and this Z is called the surface. Okay. So in this way, there is a graph of a very this selected curve, which is very necessary for you. Let us suppose this example graphing a function of two variable, and the function is given 100 minus x square minus y square, and plot the label of the label curve. Then this may be the figure. For this, the surface is z is equal to f of xy, and it is given 100 minus x square minus y square. This is the graph of f. Okay. If you plot, then you will find like this. Okay. And here the various level of the curve. Various level. This you look. This is your f of xy is equal to 75. But here this is equal to z. Z. This is the vertical z. This is x-axis. This is y-axis. Okay. And this curve is f of xy is equal to 51. A typical level curve as the function domain. Okay. So just you find out, you calculate some calculation and then you'll find out. But here, this curve is f of xy is 0. Okay, this is f of xy is 0. Okay, and this is axis. Okay, so in this way, you can plot the various curves just to discuss what is the meaning of level curve. Okay, so level curve in this way you can find and you can discuss. Then for the limit, there as you discussed and you know, in case of single variable, so again, you find out and you do practice for the different rules of limit that is very parallel to single variable. In the following rule hold: if L, M, and K are real numbers, then limit x, y tends to x naught, y naught, f of x, y is equal to L, and limit x, y tends to x naught, y naught, g, x, y is equal to M. Then some rule you know, if you impose the limit into variable also, then this is distributed, means L plus M. Difference rule is, if you write here negative difference of two functions, then limit also distributed, means L minus M. Now product rule say the limit of x, y tends to x naught, y naught, f of x, y dot g, x, y, the limit is limit. You can write limit x, y, x, y tends to x naught, y naught, f of x, y into limit x, y tends to x naught, y naught, g, x, y. It means L into M. Okay, so constant multiple rule means limit x, y tends to x naught, y naught, k f of x, y is equal to k times limit of x, y tends to x naught, y naught, f of x, y. Okay, so this is k into L. K is any number. And the quotient rule is, if you divide the numerator and denominator, then limit will be distributed. Limit will be here also, limit will be here also. In result, you can say L divided by M, provided M should be not 0. So calculate, you may calculate the limit in this two variables. X, y tends to 0 to n, x minus xy plus 3 divided by x square plus y plus 5xy minus y cube is equal to, how you can say, so you just look, x, y tends to 0 and 1, x is 0 and y is 1. You put here 0, 0 and 1, you will get minus 3. So similarly here, x is 3 and y is minus 4, then you will get 5. So this is quite simple. So don't hesitate, you do some practice for the two variable also. Limit x, y tends to x 0, 0, x square minus xy divided by under root x minus under root y is this thing. This way you will get 0. Okay. Similarly, what is the continuity in the two variable function? The function f of xy is continuous at the point x naught, y naught if f is defined at x naught, y naught and limit exists, of course, and the value of the function is are equal. Limit x, y tends to x naught, y naught, f of xy is equal to f of x naught, y naught. A function is continuous if it's continuous at every point in its domain. So this is the meaning of this. Okay. Now, next question already we have already did in the previous PPT also. Here also for practice, if finding partial derivative at a point, so find the values of del f over del x and del f over del y at the point 4 minus 5, and this simple function is there. Then you can differentiate, keeping y as a constant. Then you will find del f over del x, and this value you will get 2x plus 3y. Now the similarly, del f by del x at 4 minus 5. You can put in place of x here 4, and in place of y minus 5, you will get 7, minus 7. Now similarly, with respect to y, keeping x as a constant, then you will get this value. And after putting, you will get 13. So del over del y of this, So this is equal to, you look, keeping x as a constant, this is 0, but here this is 3 into x into 1, and in the resultant you will get value 13. Okay, sometime you know key in differential calculus we always go for chain rule. So this is the beautiful picture of the chain rule, how it works. If w is equal to f of xy, h are differentiable and differentiable function, then according to chain rule, you look, if w is equal to f of xy, then you can differentiate del w over del x, del w over del y. Here, if this is x and this y and this is t, if look, if the parametric coordinate is t, then you have to find out with respect to x and t dx by dt, and this is dy over dt. Then this is called the intermediate value. So here the function was here, okay, and the intermediate value of this x and y is defined into the term of t, okay. So independent term, then you can write down okay, dw by dt is equal to del w over del x dx by dt plus del w over del y dy over dt. It means in the next lecture we will discuss total derivative, okay. So in total derivative we will discuss something more about this. Now, we have already did in the last lecture, the partial derivative is this. You know, keeping one function constant, you can evaluate the second function, and then moving further, there is one term of homogeneous function. What do you mean by homogeneous function? An expression of the form a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 y square up to a n y n, in which every term is of the nth degree, is called homogeneous function of degree n, and this can be rewritten as, you can take xn from here outside, then you will be able to write this function like this. And just to check the degree of this function, now this is y by x, this is also y by x, this is also y by x. Thus, any function f of xy which can be expressed in the form of this x power n phi of y by x is called a homogeneous function of degree n in x and y. This is beautiful definition of the homogeneous function. You must remember this. And then the Euler's has given one theorem which is very important in partial differentiation. So it is, your attention is required on this theorem, Euler's theorem on homogeneous function. If u is a homogeneous function of degree n in x and y, then x du over dx plus y du over dy is equal to nu. You must remember first this definition. Okay, in general, if u be a homogeneous function of degree in x, y, z, and so on, then x du over dx plus y du over dy plus z du over dz plus t times du over dt is equal to nu. So this is the general definition of homogeneous function. Now, for example, let us suppose this example is given here, so that x du over dx plus y du over dy is equal to 2u log u, where log u is given. This is the function of x and y. Then how you will solve? Z is equal to, you know, z is equal to log u, and log u is given. This is, so you can simplify it by taking x square here. You can by taking x cube outside and from denominator x outside, here you will get x square, and the function on simplification you will get 1 plus y by x whole cube divided by 3 plus 4 into y by x. It means z is a homogeneous function of the degree. कितनी degree है यहाँ? 2 है. So of the degree 2 in x and y. By Euler's theorem, you know, just you apply the Euler's theorem, then you are able to write x dz over dx plus y dz over dy is equal to 2z n. N क्या आया यहाँ? 2 आया. So 2z you can write here. Okay. So but dz by dx is, just you go through, then you will find 1 by u du over dx, and what is dz by dy? 1 by u du over dy. Now put all the value here, then you will get this equation. After putting the value, you will get this equation, and just simplify it. Then after simplification, you can find x by u du over dx plus y by u du over dy is equal to 2 log u.